Hey guys, welcome to Binary Field. Today we are going to see how to move all the occurrences of the element to the end of an array. So we are given an array of integers. Basically, it can be anything, and also an element which we have to search all its occurrences and move them to the rear end of the array. This array will transform into this array, and there are few caveats here. First of all, we cannot use any auxiliary space. That is, we have to solve this in O1 space complexity, and also the order doesn't matter. So our answer array can be 1465, 6145, and they. You can pause this video and try to solve this on your own. We'll get back to the solution few seconds. Now let's get to the solution. The first solution that comes to our mind is we can sort this whole array, group all the twos and put them to the end. But it will take n log n time, as normal sorting algorithm like heap sort, merge sort, quick sort has an average time complexity of n log n. Now the question arises, can we do better? And the answer is definitely yes, we can do better. What we will do is, first we will assign two variables. Let's say the first one is I, and we will position at the zero index. That is the first element, and let's make the second element of different color, uh, and name it as J. Now we will check if our I is equal to 2 and J is not equal to 2. Only in that case we will swap our I and J. Here we can see I is equal to 2 and J is equal to 5. So we can swap them down. Yeah. Now we will increment I and again and decrement J. And we again see that it is equal to 2. So we decrement J again till it reaches a number which is not equal to 2. Then we again increment I, as 4 is not equal to our target element, that is 2. So we increment it again. Now I is again equal to 2 and J is equal to 6. So we will swap both of them. Now again J is equal to 2, so we decrement it again and increment I. As we can see, these both are overlapping, so we can close the loop here. So our time complexity of this solution will be O of n, and our space complexity will be O of 1. It will be O of n because we are traversing the loop only once, and we are going through each and every. Now let's get to the coding part. First, we will initialize two pointers, I and j. I will be equal to our first element, that is 0, and j will be equal to last. Not the element, actually the index of the element. Now we know we have to move from left to right. So none other than while loop will be best in our case. So while I is less than j, we have to iterate. While iterating, we also have to check if our j is equal to our element. So while j is equal to our element, we decrement j. So what's happening is, let's say we have this array 2, 3, 4, 5, 2, 2, 2. So I is at 0th index and j is at last. So j is already equal to 2, so there is no point in swapping it. So we decrement it again till it reaches 5. As it reaches 5, we stop and swap with our I. So it becomes 2 and here comes 5. So let's write the code for swapping. First, we have to check if our I is equal to our element. Only then we have to swap them. In Python, you can swap in single line. You just have to use this comma array. After that, we can just increment our I, and as we come out of this while loop, we can return our array. But I don't know if you guys noticed or not, I have missed one important thing. Uh, Let me show you by giving an example. So let's say I have an array like 2, 4, 2, 2, 2, 5, 6, 2. Starting from the I equal to 0 and j equals to love, I will be first at this 0th index and j will be at last. Then we will enter this loop and j will decrement. So j will get to 6 and I is still at 2. We see I is equal to our move and we swap them. So 6 will come here and 2 will go there and j is here. Then we increment I. Then I comes to 4. Then we again enter this loop and j is again equal to 2. So it iterates again and reaches 5. And I is at 4. I is not equal to move. So I increment again. So we are now at 2. So we again checks for if our j is equal to 2 and j is equal to 5. So we do not enter this loop and then again checks for I and we see that I is equal to 2. So we do swapping again. At this point we know we have done our thing and moved all the 2's in the end, but the code doesn't know. So code will continue to move on. I increments again, so I become this 2 and j is at this 2. So I is still less than j and j will now this condition will fulfill. So j will decrement again till it reaches 5. At this point j is less than I, so it should break, but we are in the loop, so it will execute fully. And I is here and j is here. I is equal to 2, so we swap again. So it becomes 2 and it becomes 5. After that, I increments and this time j is here and it is less than I, so it breaks and we return our error. So in this condition, our code will provide a wrong solution. What we can do is we can add a additional check here, where we can check if our I is less than j. So so when j will reach I, it will not execute and it will break out of the loop. That's it, guys. I hope you like this video.